This problem is categorized under easy difficulty, but I wouldn't say it is very easy, because to come up with a solution that works in a time complexity that is better than order of n requires you to think out of the box. Hello friends, welcome back to my channel. First, I will explain you the problem statement and we will look at some sample test cases. Going forward, we will see how you can use the array indexes to derive some insights, and that should give you a hint. After that, we will use the binary search method to arrive at an efficient solution, and as usual, we will also do a dry run of the code so that you can understand and visualize how all of this is actually working in action. Without further ado, let's get started. First of all, let us try to make sure that we are understanding the problem statement correctly. And this problem feels really simple when you just read it. So what is happening over here? You are given an array of positive integers that is in a strictly increasing order, right? And you have to find out the kth missing number. And you are given a value of k, correct? So for example, in my first test case, I have an array that looks like this. All the numbers are in an increasing order and the value of k is 3. That means you have to find out the third missing number. But where are these missing numbers? To find them out, what you need to do is you need to write down all of your positive integers. So I start writing them like this. And which numbers do I already have in the array? I already have a 1, then I have a 3, I have a 4, I have a 5, and I have a 9. Correct? So which numbers are missing? 2 is missing, 6 is missing, 7 is missing, and 8 is missing. The problem asks you that, okay, tell me the third missing number. So which is the third missing number? 2 is missing, 6 is missing, and then 7 is missing. 7 is the third number, correct? So for this particular test case, 7 will be your answer, right? Similarly, when you look at your second test case, this time your array starts from the number 2, correct? And the value of k is 5. So once again, what do? Just start writing down all the positive integers. And which numbers have I already covered? I have a 2 over here, I have a 3, I have a 4, I have a 7, and I have an 11, correct? So what are my missing numbers? 1 is the first missing number, 5 is the second missing number, 6 is the third missing number, 8 is the fourth missing number, and 9 is the fifth missing number. The value of k is 5. So for this particular test case, 9 is your answer, right? So this is a scenario when you can find the missing number within the range of your array. The last test case is kind of tricky. You have an array 1, 2, 3, 4. And then I'm asking you, okay, tell me the second missing number. You would say that, okay, I'm starting from the beginning and 1, 2, 3, 4, all the numbers are occupied, correct? But instead, follow the same approach. Write down all of the integers. When you start writing them down, now check. What numbers have you already covered? You have covered 1, 2, 3, and then a 4, right? I am asking you, tell me the second missing number. The value of k is 2. So the first missing number is 5 and the second missing number is 6. So for this particular test case, 6 will be your answer. So this is what particularly you have to do in the question. If you feel that now you have understood it even better, feel free to first try it out. Otherwise, let us dive into the solution. To come up with a solution, we must first understand what all information can be derived from an array data structure. So right now, my array is empty, correct? An array gives you two pieces of information. The first piece of information are all of the numbers itself. And the second piece of information that you get are all of the array indexes, right? Why are these indexes important? Let us say I have a condition where none of the numbers are missing. So my array will be something like this. So this is a condition when none of the numbers are missing, right? And how can you derive these numbers? If you notice closely, each of these numbers are 1 greater than the index, right? So if your array is very huge, let us say you have 100 elements. Then at the 100th position, if no number was missing, what will be the number over here? That will be this index plus 1. That means 101. So these indices, they can determine that if no number was missing, what should be the element at this particular position, right? So we can derive all of these numbers just by adding a 1. So if we see any discrepancy in any of these elements, we should be able to identify it, correct? So that is the technique we are gonna use. We already know that at these positions, this should be the number when none of the numbers are missing, right? But over here, I have this sample test case and we will try to plug in all of the values. Remember that you have to find out the third missing number, but we will get over there. Just stay with me and it will become perfectly clear. So I will try to populate in the first number. I get a 1. And if you notice, the element should have been a 1 over here. That means none of the numbers are missing up till this point. And you can also find it out by 1 minus 1. And that gives you a 0. That means up till this point, 0 numbers are missing. No numbers are missing at this point, correct? Populate the next value now. The next value you have over here is 3. And if you notice, this index is telling me that the value over here should have been a 2 instead, right? So that means some numbers are missing. How many numbers are missing? You find it out by 3 minus 2. So 3 minus 2 and that gives you 1. So I know that up till this point, one number is missing, correct? That number is in fact 2, right? You have to find out the third missing number. So you can be very sure that up till this point, you won't find it because up till now, only one number is missing. Now move ahead. The next number you have is 4, but instead you should have a 3 over here, correct? So once again, what do? 4 minus 3 and that gives you 1 again. Up to this point also, only one number is missing. So we can keep going ahead. The next number is 5 and according to the array index, 4 should have been over here. So to find out how many numbers are missing, you do 5 minus 4 and that gives you a 1 again. So up till this point, I know that only one number is missing in my array. That was the number 2 in fact, right? Now populate the last number and things will get clear. The last number I populate is 9. But according to this index, 5 should have been at this place. And that is telling me that some more numbers have gone missing. And how many numbers are missing? 9 minus 5 and that gives you 4. So up till this location, 4 numbers have gone missing. Now I have very important piece of information available. At every location, I know how many numbers have gone missing. So up till this location, only one number was missing, right? And suddenly at the last location, 4 numbers have gone missing. You have to find out the third missing number, right? So definitely this third missing number, that will be somewhere between here. That means between 5 and 9, correct? And you already know that up till 5, only one number was missing, right? You have to tell me the third missing number. So I can do 3 minus 1 and that is a 2, correct? That means after 5, if I find out 2 more numbers, that will be my answer, correct? So what we do is we take 5 and then plus 2. So that gives me a 7. And that is exactly what we did, right? Up till 5, you only had one missing number, right? And that was 2. You find it out over here. And then you have to tell me the third missing number. So you do 3 minus 1 and that gives you a 2. So you move 2 spaces ahead and you get this number, which is your answer, right? To solidify this concept, let us look at one more test case. Over here, I have this array, right? And what I will do is, I will start populating these elements one by one. The first element I have over here is a 2. And from this index, I know that the first element should have been a 1 in fact. So up till this point, how many numbers are missing? That is 2 minus 1 and it gives you a 1. So I know that up till the first location, only one number is missing, right? Populate your second element now. The second element is 3, but according to this index, the element should have been 2. So how many numbers are missing? 3 minus 2 and that is a 1. Go on to the next number. You have a 4. According to the index, it should have been a 3. So how many numbers are missing? 4 minus 3 and that is a 1. Move ahead. The next number is 7. But according to this index, the number should have been 4 over here. So how many numbers are missing? 7 minus 4, and that gives you a 3. So even up till this point, only 3 numbers have gone missing. But I have to find out the 5th missing number. That means I have to keep moving ahead. The next number I have is 11. But according to this index, it should have been a 5 over here. So how many numbers have gone missing? 11 minus 5, and that is a 6. So I know that up till this location, 6 numbers have gone missing, and up till this location, 3 numbers have gone missing. I have to find out the 5th missing number. So definitely I will find this 5th missing number somewhere between here, right? After 7 and before 11. Up till 7, I am missing 3 numbers. So I can do 5 minus 3, and that gives me a 2. That means if I add 2 to 7, then I will get my 5th missing number. So I do 7 plus 2, and that is a 9, right? And once again, if you remember from your example, up till 2, I was missing 1 number, and that was 1. Up till 3, I was missing 1 number, and that was 1. Up till 4, I was missing 1 number, and that was a 1 again. Up till the number 7, I am missing 3 numbers. And these 3 numbers were 1, 5, and 6. Up till 11, I am now missing 6 numbers. And these are all these 6 numbers. You have to tell me the 5th missing number. So up till here, I have missed 3 numbers. Correct? So that is why 5 minus 3, and that gives you a 2. That means after 7, if I do 2 plus, then I will get my 5th missing number, and that is 9, which is your answer, right? So this is an approach which works in a order of n time complexity, because you are traversing your array only once, and you are just looking at all of these differences. That means just the difference of element from this index, and that is telling you that, hey, these many numbers are missing. As soon as the number of missing numbers get above k, you can just apply this calculation and then find out, hey, this was the missing number. So this approach works in an order of n time complexity, but you have to find out a better time complexity, and that means binary search. If you have understood so far, applying the binary search algorithm is very, very simple. So up till now, what have we done? We had all of these elements, and for every location using these indexes, we found out how many numbers are missing, right? So 1, 1, 1, 3, and 6. These are the missing numbers, correct? And what do you have to do? You have to find out the 5th missing number. So it becomes very, very simple. You take up a low pointer, and then you take up a high pointer. And after that, you just apply the binary search technique to find out 5 between these 2 indexes. Applying binary search is very, very easy. So what will happen is, these pointers will start to converge in an order of log n time complexity. And eventually, you will find out that, okay, 5 will exist between 7 and 11. Correct? You have already found out 3. You have already found out 7. So what do? You do 5 minus 3, and that gives you a 2. And then to eventually get your answer, you take up this element 7, and then you add up this over here. And that gives you a 9. And 9 is simply the answer. So this is how you can take the advantage of binary search to get a solution that works in order of log n time. Now, if all of this is clear to you, writing the code for this is very, very simple. On the left, I have the exact code to implement this solution. And on the right, I have this sample array that is passed in as an input parameter to the function find kth positive. And notice that this code is really, really simple. It is just an implementation of the binary search algorithm. You have a left pointer that starts at the first location, and you have a right pointer that starts at the very last location. And then you just start a while loop until left is less than right. So after finding the mid element, you will start to converge. But where do you apply the binary search? You apply the binary search on the indexes, not on the elements itself. That is why we were adding 1 to the indexes, right? So just use this approach and you will be able to find out the location of the left and right pointers. Once you find out where the left and right pointers are, returning the element is very, very simple, right? The time complexity of this solution is order of log n because you are performing the binary search approach And the space complexity of this solution is order of 1 because you are not taking any extra space to arrive at your solution. I would also like to discuss one of the edge case associated with this problem. So let us say you have your sample test case like this, correct? And once you populate all of your elements, and now you try to find out, okay, how many elements are missing at every location? You will get a 0 at every instance, right? Because none of the elements are missing, correct? So in such a case, if you ask me, okay, how do I find out 2 between these two locations, correct? When all of the elements are 0. In such a case, what will happen is when your binary search algorithm starts, both the pointers will be at the left and right location. In a binary search approach, you will look at the middle element. This is not 2, right? So what will binary search do? It will move the left to middle pointer. And if you're not finding the element once again over here, binary search will keep on moving the left pointer. So this left and right pointer will eventually coincide and they will be at the last position itself, correct? And this is where you exit the loop. So you haven't found out the element and still the value of k is 2. So what do you do actually? You just do 2 minus 0. And what does that give you? 2 minus 0 is 2 again. And to find out the second missing number, you once again apply the same approach. You add 2 to whatever element you had over here. So 2 plus 4, and that gives you a 6. So once again, this gives you 6 is your answer. Notice that the approach is same. In our previous example as well, once you had the left and right pointers, the left pointer was pointing at this particular position, right? So what did we do? 5 minus 3, and that gave us a 2. And then we added this 2 to this element over here, 2 plus 7, and that was the answer, right? And this is the exact same thing that we do over here. That is why if your concepts are clear, none of the edge cases will escape you. I hope I was able to simplify the problem and its solution for you. Whenever you see a problem, or rather an interviewer asks you that, hey, can you come up with a time complexity that is better than order of n? This is a very good indicator that you have to apply the binary search technique somewhere, because that is the only way that you can reduce the time complexity less than n. A n time complexity means you are scanning every element of the array, and going better than that usually means binary search. One more indicator is that whenever you have a sorted array, when things are sorted, searching can become very, very fast, thanks to the divide and conquer technique that is provided by the binary search algorithm. So have you seen any other such problems which ask you to come up with an approach that is even better than order of n? Or what about this problem itself? While going through the video, did you face any problems? Or do you have any other method by which you can come up with an even better solution? Tell me everything in the comment section below and I would love to discuss all of it with you. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This motivates me to make more and more such videos where I can simplify programming for you. Also, a huge shout out to all the members who support my channel. You guys really keep me going. And as a member, you do get priority reply to your comments as well. Stay tuned for my next video. Until then, see ya.